Ah, the infamous cold start. If you've worked with any serverless backend tools, including Cloud Functions, you've probably heard of this performance behavior. A cold start is the delay that your function code experiences when it's fired up in a new server instance. Some delay is unavoidable, and it's natural with the way that Cloud Functions scales up and down to meet the demand on your function. But is there anything you can do to improve this? Turns out there is, and that's what I want to talk about today. My name is Doug, and thanks for joining me in this last part to this series on Cloud Functions. Okay, the key here is to pay attention to what you're doing in the global scope of your function code. As you know, with the Firebase CLI, the way you declare each of your functions is in a single JavaScript file typically called index. Like any node module, it has to export everything it wants to expose to other modules that import. So what you have to do here is export all the functions that you want to deploy to Cloud Functions. So let's say you have a single function, f1, in your index, and it necessarily imports the Firebase Functions module along with the Firebase Admin SDK, which is common. When f1 gets triggered for the first time in a new instance, the first thing it'll have to do is evaluate the global scope. This means all the code from Firebase Functions and Firebase Admin and all of their dependencies all have to be compiled and executed. And let's not forget that the Admin SDK is being initialized in the global scope as well. Only after all this is complete can f1 begin to execute. This is all part of the total cold start time for the function. For the next invocation of f1 on this server instance, none of this code in the global scope has to be repeated, so it'll be faster. But new server instances allocated for f1 will still have to pay the cold start time of repeating all of this work. For this one function, there's not much we can do to improve the cold start time. But let's say we add another function, f2, and this one does not use the admin SDK. When f2 gets deployed to its own new server instance, it has to pay the cold start cost of importing Firebase Functions, Firebase Admin, and initializing the admin SDK. But the cost of dealing with the admin SDK is completely unnecessary in f2 because it was never used. I'm sure you can see here that the key to optimizing f2 is making sure that it doesn't have to pay the cold start cost of all the stuff it never uses. So let's refactor this a bit to move the imports inside the functions where they're actually used. Now we still have Firebase Functions at the global scope because that's always necessary, but the admin SDK is required and initialized only in f1. And you'll notice the initialization is only done on the first invocation in this instance because you can't init the admin SDK twice in the same process. That would make the second invocation of f1 fail. The require is actually safe to repeat because a module is only ever loaded once per process and always returns the same object. This sort of optimization is called lazy initialization because we're waiting to do the work at the last possible moment, which is pretty much how I got through high school. Anyway, you can see here that one of the keys to minimizing cold start times when you have a bunch of functions defined in a single module is to move as much global code as possible into the functions that actually need it at the time they need it. And of course, if you're not using a node module at all, don't import it. Just remove it from your project. Don't pay the cost of things you don't use. What I've shown you here so far is JavaScript. For those of you who use TypeScript in your functions, and I approve because I'm one of you, it gets a little more complicated. The equivalent module imports like these here can only be done at the global scope, and they can't be conditional or placed inside a function. TypeScript doesn't allow that. To optimize this case, you'll need to use a dynamic import to lazy load Firebase Admin like this. Note the use of async await here, since dynamic imports are asynchronous and return a promise. But the problem with dynamic imports is that you'll lose valuable type information from the module if the import happens outside the scope of the code that actually needs to use it, which kind of defeats the purpose of using TypeScript. If you like to break down your code into functions, which is normally a good idea, you'll need to bring that function back up into scope where the module was imported. Yes, it's perfectly valid to put functions inside other functions in JavaScript and TypeScript. There are a few more things to keep in mind. If your function ends with an error, the server instance where that happens will be deallocated because Cloud Functions won't know if it's safe to reuse that instance for future events. A simple bug in your code could make cold starts more frequent, so be sure to test thoroughly. Oh, and if you had the idea to ping your function periodically in order to keep it warm, you should know that won't eliminate cold starts entirely. It may just make them less frequent, since server instances will come and go outside of your control. And you'll still be paying for those pings, which will need to happen frequently. Minimizing the amount of work your function performs at the global scope for all the code that it imports, both directly and indirectly, is the key to minimizing cold start time. But if the cold start times are unbearable for your application, you may want to consider running your own server instances using something like App Engine, which gives you more control over its behavior. If you do this, you're going back to the work of managing your own servers and paying for them to be available all the time. And of course, you won't have direct access to all the background triggers offered by Cloud Functions. This is the trade-off you'll have to make. Cloud Functions can save you time and money during development, as long as you're aware of how it works and you're willing to write your code in a way that suits the system. I hope this series has been helpful for your understanding and for your code. Thanks for tuning in here to the Firebase channel on YouTube, and I'll see you here soon.